So in this question, consider the given figure and choose the correct option. Here it is the energy profile diagram. On y-axis you have energy, on x-axis you have reaction coordinates. This reactant will be converted to the product by taking this minimum energy. This is called as threshold energy. But that threshold energy is not there for the reactants. Reactants, to get the threshold energy, have to supply the activation energy. That activation energy is E1 plus E2, that is considered as an activation energy for the forward reaction. And now product will be converted to the reactant in a backward reaction. For that one also threshold energy is same. But this E1 is considered as the activation energy for the backward reaction. Activation energy of the backward reaction. Clearly you can tell one thing, if from this energy profile diagram, energy of the product is greater than the energy of the reactant, which indicates the endothermic reaction. So we know that energy is always inversely proportional to stability. That's why in endothermic reaction, product is unstable when compared to reactant. Reactant is stable. So from that one, activation energy of the backward reaction is E1 and the product is more stable, which is a wrong answer here. Activation energy of the forward reaction is E1 plus E2. Product is more stable than the reactant. It is also wrong. Activation energy of the forward reaction is E1 plus E2 and the product is less stable than the reactant, which is the correct answer for the given question. So here the list 1 partial derivatives are given. Here the thermodynamic quantity we have to match with the list 1 and list 2. So we know that Cp, heat capacity at constant pressure, is equal to dH by dt at constant pressure. So dH by dt is there at B. So B is matched with 1. B is matched with 1. And we know that from electrochemistry we can write that delta G is equal to V delta P minus S delta T. Most of the galvanic cells which takes place at constant pressure, then delta P is taken as 0, then delta G by delta T is equal to minus S. So here it is a minus S. That will be equal to dG by dt at constant P. So here it is A is matched with 2. And now from this equation dZ is equal to VdP minus SdT. If I am going to take temperature as constant, then dt is equal to 0. Then delta G is equal to V delta P. Then delta G by delta P at constant temperature is equal to V. That is around 4. So dG by dP at T is equal to V. So C is matched with 4. And clearly you know that du by dt at constant V is equal to heat capacity at constant volume CV. Then D is matched with 3. D is matched with 3. So the correct option for this question is 2, A2, B1, C4, D3. Density of 3m NaCl solution is 1.25 gram per ml. Molality of the solution is, we know that molality is equal to number of moles by weight of the solvent in kgs. So 3 molar solution means 3 moles of solute is present in 1 liter of the solution. So volume of the solution is 1 liter, that is equal to 1000 ml. 1000 ml. So density of the solution is 1.25. Density is equal to mass of the solution by volume of the solution. 1.25 is equal to mass by volume of the solution is 1000. Then mass of the solution is equal to 1250 grams. But we require that mass of the solvent is equal to mass of the solution 1250 minus mass of the solute 3 moles, and the solute is NaCl whose gram molecular weight is 58.5. Then you can get the mass of the solvent as 1074.5. 1074.5. That will be equal to 2 point. So it is there in grams. That's why we have to multiply with 1000 here. So 3000 by 1074.5, that will be equal to 2.79, which is there on option 4. The molar solubility S of zirconium phosphate of the molecular formula. Molecular formula is given as Zr3 PO4 4 times, which dissociated as 3Zr4 plus 4 PO4 3 minus. Let the molar solubility S for the Zr3 PO4 4 times, then it will be 3S, here it will be 4S. Molar solubility means S mole per liter. Ksp is equal to concentration of Zr4 plus whole cube into concentration of PO4 3 minus whole power 4. That will be equal to 3S whole cube into 4S whole power 4. 9 into 327 into 4 4s are 16, 16 16s are 256. 256 here into S power 7. Then S is equal to Ksp by 27 into 257 whole power 1 by 7, which is there on option 1. That means Ksp by 6912 into whole power 1 by 7. Option 1 is the correct answer for this given question. Statement 1 is spectral line will be observed for 2px 2py transition. It is from atomic structure. So both 2px and 2py are degenerated orbitals for any atom, for hydrogen or an hydrogen-like species. In between the two degenerated levels, there is no transition. If there is no transition means no spectral line is formed. So, but here it is spectral line is observed is given, so it is a wrong one. 2px and 2py are degenerated orbitals. Yes, correct only, which are having same energy and the same shape also. Statement 1 is wrong, but statement 2 is correct. Option 4 is the correct answer for the given question. It is a statement question. Statement 1, corrosion is an electrochemical phenomenon. Yes, it is correct only. Which pure metal acts as an anode? Correct only. And impure metal acts as a cathode. So during the rusting phenomenon, for example, if iron undergoing rusting, pure iron is acting as an anode. At the same time, impure iron, it is nothing but rusted iron, which is acting as a cathode. So statement 1 is correct. Statement 2, the rate of corrosion is more in alkaline medium. It is wrong. It is more in acidic medium, because in air we have CO2 is there, which reacts with the water vapor to give rise to H2CO3, and this H2CO3 is the weak dibasic acid, which has been dissociated as H plus and HCO3 minus. In the presence of H plus, O2 undergoes a reduction to form OH minus. That's why rusting takes place more easily in acidic medium. Alkaline medium, it is wrong. Statement 1 is true, statement 2 is false. Option 4 is the correct answer for the given question. It is a question from thermodynamics. Consider the following cases of standard enthalpy of reaction. C6H6 plus 7 by 2 O2 uses to 2 CO2 plus 3 H2. It is a combustion for ethane, and delta H value is given as minus 1550 kilojoules. C graphite combustion is also given, and H2 combustion is also given. The magnitude of delta H naught for C2H6 gas you have to find the standard enthalpy of formation of ethane gas. So let us consider, you have to write the equation for the standard enthalpy of formation for the ethane. So 2C graphite plus 3H2 gas gives rise to C2H6 gas. For this one, you have to find the value of delta H here. So this is the formation of 1 mole of ethane from its standard set of elements, carbon, graphite, hydrogen, H2 gas. Now how to get this equation from these three equations? So in order to get this equation, you have to multiply the second equation by 2. So 2C graphite plus 2O2 gas gives rise to 2CO2 gas. Delta H2 is equal to minus 2 into 393.5 kilojoules. And I have to multiply the third equation by 3 because 3H2 is there. That's why 3H2 plus 3 by 2O2 gives rise to 3H2O. Delta H is equal to minus 3 into 286 kilojoules. 286 kilojoules. And you have to get the 1 mole of ethane. You have to reverse the first equation because the C2H6 is there for the products for the required equation, but C2H6 is there on the reactant for the first equation. You have to reverse the first equation. Then you can get 2CO2 plus 3H2O gives rise to C2H6 plus 7 by 2O2. Delta H is equal to plus 1550 kilojoules. If you add these three equations, 2CO2 gets cancelled. 3H2O gets cancelled. 7 by 2O2, 3 by 2O2 plus 2O2 gets cancelled. 2C plus 3H2, you can get C2H6. And the value of delta H is equal to minus 2 into 393.5 plus 1550 minus 2 into 286. If you solve all these ones, then you can get the answer as 95 kilojoule per mole. 95 is the correct answer for the given question. So 20 ml 2 molar NaOH solution is added to 400 ml 0.5 NaOH solution. Final concentration of the solution is, it is from solution concept and concentration terms. Both are bases are added. That's why both are bases means the formula you have to use is the final concentration of the NaOH is M1V1 plus M2V2 by V1 plus V2. M1 20 into 2 plus M2 0.5 into 400. But the total volume in ml is 20 plus 400, that will be equal to 420. That will be equal to 40 plus 200 by 420. That will be equal to 240. 240 by 420. 0 gets cancelled. If you solve this one, that will be equal to 57.1 into 10 to the power of minus 2. That will be equal to 57, nearest integer. 57 is the correct answer for this question.